You see this question. Let m of m dx plus n dy equal to 0 be non-exact differential equation. They said it. And they have given one condition, that is dou m by dou y minus dou n by dou x equal to a into n minus b into m, where a comma b are some non-zero constants. Then derive at least one integrating factor of the given differential equation. If you observe that we have studied 1 by n multiplied with this, right, and similarly 1 by m multiplied with this, when it is a function of x, you know what is the integrating factor. When it is a function of y, you know integrating factor. And you might have seen one more case, that is homogeneous type and other type 1 by mx minus ny, right? Yeah, you may not get an idea here, so that is why some hint is also given here. So this is the hint to that question, which is there in the question paper itself. Okay, so see, they are asking us to follow these steps to answer that question. Okay, so there are let us assume that I of x comma y be its integrating factor. So when it is an integrating factor, definitely when you multiply the given expression with I, then it becomes exact, right? So when it is exact, you know it has to satisfy one condition. What is that? So let me do the steps here. In the first step, we have to expand this expression. It means the necessary and sufficient condition for exact differential equations. That is dou by dou y of im equal to dou by dou x of in. You know how to differentiate them, right? So let us just differentiate. When you differentiate, you'll get I is a function of xy, m is a function of xy. So we need to use product rule to differentiate them. So I into, you can see dou m by dou y plus m into dou I by dou y equal to, on the other side I'll have I into dou n by dou x plus n into dou I by dou x. Okay, so they asked us to expand. Okay, we expanded it. Fine. So we are done with step 1. Next, let me see what is there in step 2. So next they are asking us to compare above obtained expression with this expression. Okay, first of all, let me try to get this expression into this form, then later we can compare it, right? So here I have dou m by dou y minus dou n by dou x, taking I common. Yes, here also it is possible to take I common here and common here. Bring this expression one side. So now step 2. So bring this expression one side. So I into dou m by dou y minus dou n by dou x. Right? Now you take this expression to the other side, so that you'll get n into, you'll have dou I by dou x. I can write it like this, right? Ix minus m into dou I by dou y. You can write it as Iy, right? Now, yeah, let us compare with it. So when you compare, okay, this side you have same I into dou m by dou y minus dou n by dou x. Then you have n into ia here. So whereas here you have n into ix. So we are saying, so when you compare it, so you'll get ix equal to ia or ai. And of course here they said, right, then write the relation between ix and I, similarly iy and I, right? So the relation between ix and I is going to be ix equal to ai, and similarly what is the relation between iy and I? So that is iy equal to ib, right? In place of ix we have ia, in place of iy you have ib. So now you have two differential equations. So one, that is ix equal to ia, or in other words, let me write a into I, right? So in step 3 they are saying solve obtained differential equation in step 2, which involves ix. Yeah, so this is the differential equation which involves ix. So ix equal to ai, and here um, if you rewrite this expression, this will give you dou I by dou x equal to, what is it, a into I. And you can separate variables, that is dou I by I, which is nothing but a into dx, right? Now you can simply integrate on both sides. So when you integrate, so here you'll have ln of I, whereas on the other side you have ax plus some integration constant. Let me add ln c. So this implies, what is I? I is nothing but some constant. See here, observe one thing, you are actually solving for I by integrating with x here. So in that case we treat the constant is going to be a function of y. Okay, so this is c of y into e power ax. So this is what our I is going to be, right? So that's what step 3 says, solve the equation which involves ix. And how about step 4? Let me solve it here. Step 4 says that solve the equation which involves iy. And what is that? Which is nothing but iy equal to by. And it is similar to ix equal to ax, right? So, sorry, I think I wrote it wrong here. Iy equal to bi, right? So it is similar to ix equal to ai. So in the similar way, if you solve, you can see that I is nothing but some function of x, right? Let me assume that is c2 of x into e power by. Okay. So now step 5, use step 3 and step 4 to write I of x comma y. Okay. So in step 3 I got I is this, and in step 4, and this is what I. So let me write the I which is obtained in step 3. So let me write it. So I equal to, we are saying that is c1 of y into e power ax. So by observing these two, definitely we can guess that I of x comma y must be e power ax. Why? Because here you have c2 of x, and in place of that you have e power ax. Similarly here you have e power bx in place of c1 of y. So you can write e power bx, sorry, e power by. So this is nothing but e power ax plus by. That's it. So this is what step 5, right? So therefore now the integrating factor is going to be e power ax plus by. So now we got answer to this question. So they're asking us to derive at least one integrating factor for this. Yeah, we can say that one integrating factor, that is I of x comma y, is nothing but e power ax plus by. Okay, so this is the one of the integrating factors. This equation may have some more integrating factors, but this is one of them. Okay, so now this actually gives us a new formula. So far you have some formulas. Now you can add this one as a new formula to your notebook, right? So I hope you have understood how to solve this guy. So every information is given here only, right? So the hint is given here, the question is given here, and the hint is given here, right? So I hope you understand. Thank you.